Welcome to PhilotiMaths, fighting problems one step at a time.
Hello and welcome to PhilotiMaths. Today we're having a lesson on differentiation. Let's have a look at an example to start. Okay, so we've got 3 examples here, but before we have a go at tackling these, we need to firstly know what is differentiation. Well, differentiation is when we take a function, f of x, and we find what's called its derivative, which we notate as f dash of x. Well, how do we find f dash of x given the original function, f of x? Well, in this video we're going to look at a specific case, which is when f of x takes the form x to the power of n, where n can just be any number. And in this case, if f of x is equal to x to the n, then its derivative f dash of x is actually equal to nx to the n minus 1. So what we do is we multiply by the power and then subtract 1 from the power. Okay, well, what does any of this actually mean? Well, it turns out the derivative is actually very useful if we want to find the gradient or the steepness of the function. But in this video, we're just going to simply look at how to actually calculate the derivative given different examples of f of x. So let's get started. Okay, in this first example, we've been asked to find f dash of x when f of x is equal to x to the power of 4. Now, if we go back to our rule up here, we're looking at f of x is equal to x to the power of n. So n, the power of x, in our example, is 4. So n is 4, which means that f dash of x is not nx to the n minus 1. In this example, it's 4x to the power of 4 minus 1, which is 3. So the answer is 4x cubed. In the second example, we've got to find f dash of x when f of x is equal to x squared. So again, using our rule, we're looking at f of x is equal to x to the power of n, which means that 2 is equal to n. Which means that f dash of x is not nx to the n minus 1, it's instead 2x to the 2 minus 1, which is just 1. Now, we don't have to write the power of 1 because x to the power of 1 is simply x. So we can leave this as just 2x. Now, this third example is a little bit different because we've got this 7 here next to the x cubed. Well, to start with, we're just going to ignore the 7 and imagine it was just x cubed. So let's go back to our rule. If f of x is equal to x to the n, then f dash of x is nx to the n minus 1. Well, n, the power of x, in this example is 3. Which means that f dash of x would be 3 multiplied by x to the power of 3 minus 1. Well, 3 minus 1 is just 2, so that leaves us with 3x squared. Okay, so now how do we incorporate the 7? Well, remember 7x cubed really means 7 multiplied by x cubed. So to get the final answer, we're simply going to multiply this whole thing by 7. So this leaves us with 7 times 3 times by x squared. Well, 7 times by 3 is just 21. So that gives us the final answer as 21x squared. Now, in this next example, we've been asked to differentiate simply x. Well, it's not clear what the power of x is, and if we're going to be able to use this rule that we've been using before, we need to know what that power is. Well, we can also write x as x to the power of 1, because anything to the power of 1 is just itself, so n is 1. Which means we can now use this rule, and f dash of x is just 1 multiplied by x to the power of 1 minus 1, which is 0. Well, x to the power of 0 is just 1, because anything to the power of 0 is 1. So this is now equal to 1 multiplied by 1, which is just 1. Okay, so if we're ever given x, then we know that that differentiates to just give 1. Now, in the second example, we've been given 5x to differentiate. Now, to start with, we're just going to pretend that that 5 is not there and that we've just got x. Well, x is exactly what we differentiated in example D, and we know that that gives us 1. So x differentiates to give 1, and now we just need to take into account the 5. Now remember, 5x really means 5 multiplied by x, which means that we're just going to multiply this 1 by 5, which will give us the final answer as being 5. Now, in this final example, we've been asked to differentiate 4, which doesn't involve any x's, which means that we can't use this rule that we've been using. So how do we differentiate this? Well, it turns out that any number on its own without any x's simply differentiates to give 0, which means the final answer is 0. Okay, so for those of you wondering, the reason why it does differentiate to give 0 is because the derivative of a function relates to the function's rate of change. So if the function is just 4, then it's not changing, so the rate of change is just 0, which is why the derivative is 0. Thanks for watching this short video on differentiation. See you next time. Have you suffered from a maths-related injury in the last 4 months?
You're in the right channel. Welcome to PhilotiMaths.
Now in this final example it's a little bit different.
Final? You got more to do. You got more to do, you lazy teacher.
Now the question is, what is the power of x that's going on here? Well, what is the power of x going on here?
Why is it going on there?
Why is it going on?
What does it mean going on? The power of x that's going on here. Right, what power is going on here, guys? Tell me.
Well, anything to the power of 0 is just 1. So this is just going to leave us with 1 times 1, which overall is just 1.
Oh, really?
Isn't that amazing?
What is 1? You don't say.
Oh god, spare me. Thanks for watching this short video on differentiation. See you next time. See you next time. See you next time. See you next time.